Hello, everyone. My name is Jesse, and today I'll be presenting about the Java 11 journey at LinkedIn. So to begin with, I'm going to give a brief introduction on how LinkedIn uses Java. So all of our applications at LinkedIn, or almost all of them, run on top of the JVM, be it Java or another language. However, it's mainly Java. We also depend on several external frameworks in order to run our applications. Those are Jetty, Play, Samza, Hadoop, and Android. Of those five, the version of Jetty is the only one that's compatible with Java 11 at LinkedIn at the moment. The other ones have versions that are older at LinkedIn, but maybe not the open source. So all of the numbers and challenges that we face going forward in this presentation will be about Jetty applications. And you may have noticed that I talked about applications before, but we're also talking, I'm also going to talk about libraries. So applications are the piece of code that are run directly by the JVM, whereas libraries are the piece of code that are run transitively on the JVM via the applications. To give a sense of how much code we have at LinkedIn, we have 16,000 different libraries and applications. So it's pretty big, and we're moving a lot of this to Java 11. We're also moving JDKs. So originally we were on Oracle JDK. However, we've moved to OpenJDK recently. So all of the numbers you see will be related to OpenJDK. And we're also mainly on the G1 garbage collector and CMS. So to give a sense of how many applications we have on CMS and G1, we have 40,000 application instances on CMS and 65,000 application instances on G1. And also, we're mainly on Java 8 today, before Java 11 at least. I'm also going to give a quick intro about Java 11. I imagine most in the crowd will have a strong knowledge about it, so I'll try and keep it short. Java 11 is the next long-term support version of Java after Java 8. The one after that is Java 17, which comes out next year in 2021. But Java 11 was released in 2018, so it's been a while, and we are just now getting to a point where at LinkedIn we can move to Java 11. And we were very interested in Java 11 before the migration as we were doing some research, and we found that there are many improvements, especially in the G1 garbage collector. But there's also other improvements in the general JDK, such as compact strings. David Grieve has a really good article about the different reasons why you would want to move to Java 11. So I've linked it as an additional resource for this presentation, so please check it out. In addition to those improvements, we also have experimental garbage collectors in Java 11, those being ZGC and Shenandoah. And that's definitely something we want to play with moving forward. So we were also wary of a couple things before migrating to Java 11, and that's mainly the backwards and forwards incompatible changes. That's not only the bytecode level, as it's well known that the higher level of Java bytecode cannot be run on a lower level JVM. There's also incompatibilities within the JDK libraries themselves. That's like when you have something that's compiled with Java 8, it may not necessarily be able to run on Java 11 and vice versa as well. In addition to this, CMS is deprecated. As you saw before, we have a lot of applications on CMS, so that's something we have to be wary of going forward as well. And also the module path is one of the biggest changes in Java 11, or Java 9 really, but it's within our scope of the Java 8 to 11 migration. And this is something that's not mandatory to upgrade to Java 11, as you can use Java 11 with a class path. So that's what we've done. And we're considering Java 11 as a prerequisite before considering the module path at all. So for the rest of this presentation, I'll be talking about the performance numbers we see with the different garbage collectors in Java 11, as well as technical challenges we faced while migrating to Java 11 in general, and what our migration looks like in terms of the goals, progress, and plans that we've made. So first, we're going to talk about some of the performance. So far, we have a sample size of about 30 applications, mainly on Java 11. They're mostly on Java 11 in production. So we're looking at the latency and throughput as our main metrics. Some of the applications only look at one of these, but generally most of them will look at least one of the two. There are other underlying metrics that our team looks at, such as the GC metrics in terms of like collection time and pause time and other things like that, as well as CPU utilization. But in general, we found that our application owners like to look at latency and throughput as the end-all metrics. So I'm going to present a couple of examples here. Our first example is the Pinot, which is an open source data store that provides near real-time and offline data. In this case, we tested our latency by maintaining a constant throughput. And what we saw was that the tail latency in Java 11 significantly outperformed Java 8. As you can see from this graph, in the P90 latency time, the pause time or the latency time was actually very similar. However, when you look at the P95 and P99, you see significant improvements for Java 11. In addition, when we tried to push the system as hard as we could in order to find the max throughput, we found that Java 11 G1 outperformed Java 8 G1 significantly. In this case, it was over a factor of 2. Next, this is a non-open source application, so I'm going to label it as application 1. But it's essentially an API server that handles some business logic, so fairly normal. In this case, we saw a heavy reduction in P95 latency as well. The performance really surprised us at this point, as it was one of the first services that we tested. In addition, we saw when we pushed the system as high as it could go, that the throughput also increased by over a factor of 2 once again. And one of the underlying metrics that the application team actually cared about in this case was the CPU utilization. And the CPU utilization was almost halved by just going from Java 8 G1 to Java 11 G1. So definitely a big performance gain here as well. Another case is a fairly famous library called Kafka Server. Well, I guess it's an application, sorry. But in this case, they mainly cared about their latency. And what we saw was that in the tail latency, there is also an improvement in the Java 11 G1. It's not as significant as the other two that we just saw. However, in the P999, we saw an improvement of about 10%, which if you look at it in a vacuum is still fairly good, as you can get a performance gain just from upgrading to Java 11. Next, I'll be talking about another non-open source application, which I'll call application 2. So the latency for this one was very interesting because we tested it with several garbage collectors, Java 8 G1, Java 11 G1, ZGC, and Shenandoah. In this case, we saw that the latency didn't change much between these collectors. But the real interesting thing was when we looked at the throughput, when we pushed the system as hard as it could go, the Java 11 G1 outperformed G1 on Java 8, ZGC, and Shenandoah significantly. It should still be noted that ZGC and Shenandoah still outperform Java 8 G1, so it's still better in that case. Our next example is Brooklyn, which is an open source data pipeline, and they mainly care about throughput. So these metrics, EBWR, EBPR, and EPR, are all throughput metrics. And what we saw here was that G1, ZGC, and Shenandoah on Java 11 all outperformed Java 8 G1. But this was a very interesting case because we saw ZGC and Shenandoah actually outperform G1 in Java 11. But definitely we could see some significant performance gains in this one as well. So to give some concluding thoughts about the performance numbers, we saw that when we tested CMS, we could see that essentially the performance was same across Java 8 and Java 11. And when we took a look at G1, we saw that the results were high variance in that we saw some applications have no improvement at all, but others that had substantial improvements. We did not see any applications that actually had a performance regression in Java 11 for G1. Another thing that we wanted to note was that with our Shenandoah and ZGC testing, our sample size was more limited, but we did see some cases where it outperformed G1 and other cases where G1 was better, but mainly G1 seemed to perform better in general. And that's a bit to be expected from an experimental collector. Another interesting thing is that although Shenandoah and ZGC are somewhat conceptually similar, in practical results, they are not the same. We saw test cases where ZGC outperformed Shenandoah significantly, and others where Shenandoah outperformed ZGC. So in general, I think it can still be said that applications should be testing their different collectors on an individual basis. This should lead to the best results. Next, I'll be talking about the progress and technical challenges that we faced while moving to Java 11. So before the migration began, we tried to set some goals. And to get a bit of a historical context here, our last Java migration was from Java 6 to 8, and it had 12,000 libraries and applications at the time, and it took 18 months. This is not very good because the Oracle has changed their release schedule to upgrade major versions every 6 months now. So before it was every couple of years, but after Java 9, we have a new major Java version every 6 months. So 18 months is definitely not acceptable to migrate these. So our goal here was to reduce the total time needed to migrate. Our non-goal was the module path, as we consider Java 11 to be a prerequisite again. The module path has a lot of interesting features that we want to investigate in the future, but doing this, combining it with the Java 11 migration was not deemed to be feasible, as it was just too much to do all at once. And also our build system did not have good support for the module path at the time where we were designing the migration. Our build system is Gradle, but I think they added some support for it in Gradle 6.6.1, which was recently released. So that's definitely something to look forward to as well. And finally, we are trying to do a bottom-up migration, the bottom being libraries and the top being applications. We're trying to do the libraries first in order to speed up the migration, as we believe most of the libraries can be all migrated at once, since it's not actually being run in production. Our applications are the ones being run in production, which means that we treat them as first-class citizens. If we were to migrate applications first, it would mean that some libraries that may be incompatible with Java 11, if the application is on Java 11, we might face some runtime issues. In addition, this will also make the application migration much smoother, as we know most of the libraries that it depends on are already migrated to Java 11 and compatible. So next, I'll talk a little bit about the different technical challenges that we face while migrating to Java 11. So one of the biggest issues is the compatibility between Java 8 and 11. As I mentioned before, we're doing a bottom-up migration. That means that libraries will be on Java 11 before applications. And because of this, there's a big issue because the Java 11 bytecode cannot be run on a Java 8 VM traditionally. There are ways to get around this, as you can use the -source and -target flag to tell the Java 11 compiler to compile down to Java 8 level bytecode. And this lets the Java 8 VM run this bytecode. However, when we first tried to do this, we saw that application owners were trying to use new APIs right away. And even though we're compiling down to Java 8 level bytecode, if you use a new API that's available in Java 11, but not in Java 8, you will still face runtime issues in the form of no such method exceptions or anything else from API changes. As such, we decided to use the --release flag instead. So the --release flag also tells the compiler to compile down to Java 8 level bytecode. But in addition to that, it also restricts the usage of new APIs. So these are APIs that are annotated with @since 9 or higher. And it means that now our application and library owners cannot use these new APIs until we remove this release flag. So this is the way that we're enabling us to do a bottom-up migration where the libraries are moved before the applications. In addition to this, because the libraries will have a time where their code is being run in production on both Java 8 and 11, we want to enable tests for both JDKs. This is because if it's run in production, it needs to be tested as well. So doing this lets us have some stability increases, as we can see runtime issues before it hits production or any testing environment. In addition, there are some issues where we see that, for example, if a piece of code compiles with Java 8 and a piece of successfully, and the same code compiles with Java 11 successfully, it may not be able to run on a certain JVM. Our example was that there was a piece of code that was using a buffer class that it compiled successfully on Java 11 and on Java 8, but when we compiled it on Java 11 and we ran it on a Java 8 VM, there were some runtime exceptions because the method signature changed in terms of what the bytecode produced. And this is definitely not something that we could see at compile time, so it was only caught through our tests. Another way we tried to increase our migration speed was to automate some of our changes. And our automation was very simple in this case, in that we bumped the Java version as well as external dependencies, the ones that usually modify bytecode, such as ASM, CGLib, EasyMock, Mockito, and so on, as well as some internal dependencies that we know had a lot of upstreams and was incompatible with Java 11. So after we did this automation, we saw that our success rate was about 50% for all the libraries and applications, which was very good for us. Obviously, it's not just these automated dependency bumps that are letting us do this, but also the different infrastructure changes. One of the infrastructure changes we made was to add back the Java EE jars into the system. So Java EE jars were removed in Java 11, but when we did a code search, we found that there were many, many use cases of the Java EE classes. So if we were not to do anything, the success rate for the automation would tank drastically. So we added the Java EE jars back into our build system such that it can be used directly, just as it was in the JDK. Another thing that changed was the JVM options. So one of the biggest changes was the GC logging options in Java 11 with the new unified logging format. So this was completely overhauled, and we decided to just provide a default logging option and have the application owners modify their own decorators individually. This lets them acquire some knowledge about these options, as well as the fact that we don't really have great one-to-one mapping for these options, which means that we can't automate it very well. In addition to this, we used an open source tool called Jacqueline, and this lets us know which options are incompatible with Java 11. So when we found an option incompatible with Java 11, we essentially removed it from the system. There's a lot of obsolete options that come from legacy code that was in the system, and now they're useless, so we just remove them. Another thing that we wanted to implement was the ramping feature. So what ramping means is, because application owners are very skittish about going to Java 11 completely in production, even if it's been tested in the testing environments, they don't want to move to it completely in production. So what we did was to enable ramping such that some percentage of their cluster will be on Java 8 and another percentage will be on Java 11. This way, they can incrementally increase their cluster until they're fully on Java 11. And finally, one of the last infrastructure changes we've made is multi-release jars. So multi-release jars are a very controversial feature in the community, but we've treated it as a last resort solution for some edge cases. That edge case being mainly when we cannot make our code compatible with both Java 8 and 11 at the same time. So there's also another solution for this, which is to add some runtime checks to your code to have different behavior for Java 8 and 11. However, we found that these two solutions are not addressing exactly the same issue, because with multi-release jars, you can have two different compilers compile the bytecode. You can have your Java 8 compiler compile the bytecode for the Java 8 VMs, and your Java 11 compiler compile bytecode for the Java 11 VMs. This is different than a runtime check, which can only have one compiler. So yeah, these are the technical challenges we faced. And next, I'll be talking about our timeline. So Our plan originally was to move all our libraries first, as I mentioned before. But again, we're only dealing with the Jetty applications. So the libraries we're moving here are the libraries that are dependent on by Jetty applications. And when we did a code search for this, we found it was about 1,000 libraries, and we allocated 1/4 for this. That is this quarter, and so far we already have 4,000 application instances on Java 11. These are mainly our early adopters and the select applications that we've picked to move early. In addition, we have 500 libraries on Java 11, so it's progressing fairly smoothly as of now. And for the next 2 quarters, we've allocated time to migrate and ramp applications to Java 11. We've allocated more time for applications than libraries due to the fact that they're our first-class citizens and we want to be more careful. And that means that we're ramping them gradually. We also have about 1,000 of these applications. So yeah, for our future plans, when all of LinkedIn is on Java 11, we plan to enable Java 11 bytecode, and this will also allow application and library owners to use the new APIs that are annotated with AdSense 9 or more. In addition, we need to move applications off of CMS. As you saw, we have a lot of CMS applications, and we will need to pick new collectors as CMS is removed in Java 14. So this definitely needs to be done before the next Java major version bump. In addition, we want to continue exploring new use cases for ZGC and Shenandoah as we see a lot of promise in these two collectors. So yeah, if these things sound interesting to you, please let me know. You can find me on LinkedIn. We have open headcount on our team. And yes, that is the end of my presentation. Please feel free to ask any questions. All right.
Hey, can you hear me, Jesse?
Yeah, I can hear you.
Awesome, thank you. Thank you so much for your presentation. I am having issues finding my tab for StreamYard. Somehow it disappeared. But I cannot see you, but you can hear me. Probably you can see me. So I'll just pretend and not ignore the tab. So the interesting thing about LinkedIn, and people don't realize, is how big it is, the backend, and how much Java is used, right? And we've been trying to share with the Java community, especially, how big LinkedIn is and how much of Java usage LinkedIn has. And the last number we have is something around 1,500 or 1,000 microservices, unique microservices deployed. This is not the size in terms of JVM, but just the number of microservices or services implemented in Java and how they are deployed across. Do you foresee adoption of newer versions of Java? Let's say the next LTS releases Java 17 next year. Do you foresee LinkedIn adopting the next LTS version for newer services along with Java 11 across whatever is already deployed?
So we try and control these versions centrally, and I believe it's like our team's goal to give guidelines to the whole company. So we don't really want to support multiple major versions at once, but we're definitely looking forward to the next long-term support and how we can migrate the whole company to it all at once. We do have early adopters a lot of the time in order to test out the changes in the new versions. So those ones will be able to move first, but we're definitely at a point where we're trying to make our migration time smaller so that we can move quickly onto the new major versions. And this is definitely helped by the release schedule where it's every 6 months now. So there's not as many breaking changes.
Interesting. What were when the developers saw the move to Java 11, besides, of course, all the performance gains in the runtime, what sort of language features the team was excited about, or was there any discussions about new APIs, new features in the platform, in the language, besides all these JVM optimizations?
Yeah, definitely. There was, I mean, originally I talked about this, but we tried to enable the Java 8 level bytecode with the Java 11 compiler. But then we immediately saw that application and library owners were trying to use the new APIs, especially with the collections framework. So, I mean, we couldn't really allow that because we had like different levels of JVMs at that point. So we're not letting them do it now, but definitely once we're ready to do that, I'm sure we'll have a lot of usage of them.
Okay. There is a in later versions of Java, you mentioned early adopters. So are these new projects that people are able to experiment with these new runtimes? Can you talk about that a little bit?
Yeah, so we collected a lot of data about the different microservices at LinkedIn, and we try to identify like unique use cases that cover like a sample size that covers a lot of our LinkedIn use cases. A lot of the times, these are ones with a larger heap, a larger cluster size, and a lot of QPS. So we're kind of like stress testing the JVM in that way. But we also pick like some more normal applications just to get a better sense or to get more coverage on like all the different applications we have.
Okay. So for folks watching, can you name one thing on the LinkedIn interface that hits the Java microservice that people can quickly like snap like, oh, I'm in LinkedIn and this is went to a JVM, this feature here.
Mm, I mean, the way our microservices are set up, we have like our front end services calling the back end, which eventually call like our data stores and stuff like that. So it's a bit hard for me to identify exactly which ones, but I'm sure like just almost any request to the LinkedIn front end will eventually touch something that's on Java 11 already.
Excellent. That's good to know.